Hello guys, welcome to my channel Code with Arish. Today we will learn how to design and develop a security system for microservices using Springboot and OAuth. First, I will show you the technical design of this security system. I have used Miro tool to draw this technical design and here it comes. This is the technical design or the architecture of our security system for the microservice. And here you can see we have an authorization application and a user authentication service, a third-party OAuth provider, and front-end applications, which we will have a web page and a mobile application, and finally the microservice for which we have to apply the security. In front end, we will provide two options for the user to authenticate. One is using the username and password, and other one is using a third-party sign-in option. For time being, I am going with Google as the third-party provider. For the username and password option, the user has to do sign up and then login. For both the sign up and the login, the user will enter the username and password, and this has to be, I'll zoom it here. Yeah, this has to be sent to this user authentication service. So here the sign in or login request with the username and password will be sent. This will be sent to the user authentication service. Similarly, for Google sign in. So for the Google sign in this web page or in this mobile application, there will be an option like sign in with Google, a button, basically a button in the web page or the mobile application, and on clicking that button, a request will be sent to, like this, a request will be sent to the third-party OAuth application. So here, which is our Google OAuth. So this in turn, what it does is it redirect to an authentication page, which is Google's authentication page only, where the user can enter their credentials like their Google Gmail ID and their password. So once that is entered into that authentication page, which you might have seen, you all have seen that will be validated here in this Google side, and if it is authenticated, if it is a correct credential, it will be authenticated, and after authenticated, access token and the user attribute is send as response back to our web page or our mobile, our front-end application. So once receiving this access token and user attributes in our front-end application, we again sends this to the user authentication service. So user authentication service is what we are going to develop. So here we receive the access token which the Google has provided. So this user authentication service is a front-end facing service. As you have seen here, it's connected to the front-end application, which authenticates, so basically after the Google authentication, we receive an access token. Similarly, when the user enter his username or password from the web page, also we received that username and password. So these user details are not yet in our system. So this authentication service will authenticate that user, a user which was authenticated by third-party provider and has sent access token, or the user who is trying to authenticate with his username and password in our system. So all these two options are authenticated in our user authentication service, and the logic which we use, how the authentication is done, I will show you in detail while developing this user authentication service. So Once authenticated, the user details are saved in this database. So this database is attached to this user authentication service, so where we store the new user details. Once that authentication is done, what we do is we call the authorization application. So this authorization application, this is basically an OAuth2 application. OAuth2, we are using the OAuth2 application where we can configure the client ID and the client secrets. And for this configured client ID and client secret, anyone from outside this authorized application can call the token API with that client ID and client secret. And once that request is called, the token API request is called using the client ID and client secret, the authorization application has already the client ID and client credentials are there. It will check whether it is valid. If it is valid, then it is generate the JWT access token, which is again JSON web token, a token in the JSON format. It will be generated by this authorization application and sent back to the service or the client where it has called. So here also in the user authentication service, once the user is authenticated successfully, it will call with the corresponding client ID to this authorization application, which in turn will generate an access token. And this is the access, this access token which is generated by the authorization application is sent back to the web page or the mobile application as a response. And this is the access token which is used from this web page or mobile application to call other microservices. So this access token acts as the security. So here, when we generate the access token, we will have some user details like the role of the user ID, the username, which will be set in this token. And this token is signed by a key from this authorization application. So once this token is received, and when this web page or this front-end application call the appropriate microservice, we send the request for whatever API we are calling the microservice. We send the request with this access token generated. And once this access token comes to this microservice validates this token using JWK, which is a JSON web key, which will be present in this authorization application. So it in turn calls this authorization application, get the JSON web key, and validate this token using the JSON web key, so that it makes sure that this token is correctly generated from authorization application. It is signed by the correct key. So with this thing, if someone, no one can tamper this token. If, for example, if some intruder came and took this token, so only after tampering it he can alter anything in that. So once he tamper the token and send here, the signature will change. So with that token, when the microservice try to validate with the JWK from this authorization application, the signature will fail, and thereby it will not access that, or it will not accept that token and throw a signature error back. Same way, this token generated by JWK has an expiry time. That also we can configure from here. Or assume if it is configured as 10 minutes, this token will be valid for only for 10. After this token is received in the web page, it can call this microservice within the 10 minutes. After 10 minutes, if the web page again try to call this access token, when we validate here in this microservice, it will throw an exception that token is failed. So with this, we made sure that our microservice is secured by using this access token generated from our authorization application. Okay, let's now start with the development of this security system as seen in the technical design. So we'll start with the development of the authorization application first. So it's basically a Springboot application with the OAuth2 library. So let's create the Springboot project for the authorization application. So we'll click on the new project. We'll give the name of the project as authorization application, Java 17. and group ID org code with Anish, and then we'll click the create button. Okay, so the project has been created and this is the main class, so we don't want all these stuffs here. We'll remove it and this as well. Okay, that's fine. Now we want to make changes in the POM file to make it to a Spring Boot application. So first we will add the parent here, parent, and group ID. So it's org.springframework.boot, and the artifact ID is Spring Boot starter parent, and the version we can use Spring Boot 3.2.2. This provides support to the OAuth2 libraries. So that's for the parent. Now we will add the dependencies, dependency and dependency here. So we need basically two libraries. One is the web library and another is the OAuth2 library. So web library will take org.springframework.boot and spring starter web. So that one dependency, and next dependency is the OAuth dependency. So dependency again, that also comes with Spring only, or Spring Boot only, Spring Boot starter. Yeah, it's here, starter OAuth2 authorization server. So this is the OAuth2 library which will make this authorization application project to an OAuth2 application. Now for building this project we need the build plugin here. Okay, inside this plugin we will add the group ID which is same as org Spring Framework Boot, and the artifact ID is Spring Boot Maven plugin. So that's regarding the plugins, and now we'll give the final build name which is same as our artifact ID. So once it is built, we will get a jar file with name as authorization-application.jar. So that's pretty much for the pom.xml. So we have the required libraries to build our OAuth2 application. So now just click this button to load the Maven config. Yep, the libraries are loaded. You can see all the libraries here, and Spring libraries as well as the OAuth2 libraries. Now we'll come to our main class. We have to annotate this with at Spring Boot application. Here there is a curly brace. Okay, fine. Then we have to call Spring application dot run method, and the first argument is the class name. So the same class, main dot class, and arguments as we get in the main method. So that's all for the Spring Boot application. The main class. Now we will configure the application.yaml. So in the Spring Boot application, almost all the configuration which we are required to make this as an OAuth2 application can be done in the application.yaml file only. So that's the beauty of Spring Boot. If you're writing this in just Spring Security library, then obviously we need to write all config classes which are required for the OAuth2 application setup. But here we can configure everything in the application.yaml, and the rest Spring Boot will take care of it. So we'll create the application YAML file. So application.yaml. Okay, so the YAML file is created. Now we will configure this. Spring, then security, OAuth2, authorization server, client, so we are, as I told in the technical design, in this authorization application only we will configure the clients with the client ID and the client secret. And this is a client, this client ID and client secret is what a service or other application, when it calls this authorization application for token, they will send this client ID and secret which we configure here. So this configuration can be made in this application.yaml file itself. So for that, under this client we have to give an ID, because we can configure multiple clients in this application. So each client will be specified with an ID. So here I will just give us API client. This is an ID, and inside the API client ID we will have the registration. Client ID and the client secret. So client ID will give us API client ID. So this is the name of my client ID, API client ID. There is it should not be specific that this name should be same as this, nothing like that. Just for the naming sake I have given like that. You can give any name like client 1 or client 2 or API client, anything you can give here. And the client secret, API 123. So this is a secret, and before secret we will specify as no op. Now we have these two parameters, which is client authentication method and authorization done type. So client authentication method says as client secret basic, which means that whenever any application calling this authorization application for token, they send the ID and secret, it should be under the basic auth. So it should come under the header basic auth. And now the authorization grant type. So in the OAuth2 application we have multiple grant types, and here in this application I'm using this client credentials because we are just verifying the client ID and client secret only, nothing else. So that's why we have given authorization grant type as client credential. So the same way I can create multiple client here. So I have to give an ID here. So maybe I will give like this one and then register. So like this I can create multiple client, but for our application we just need only one client, so I'm keeping like that. Next is the token expiry time. So here I am giving us 36,000 seconds, which means the token generated here will be active for 10 hours and will expire only after that. Yeah, this is just for testing purpose. I am keeping like that. Depending upon the business needs, we can change this here. So that pretty much for the application YAML. So we think we have did the configuration. Now we will go to the main. So main application, so that's pretty enough. So we don't have much boilerplate code and all. Just configure the YAML and the Springboot application main class. That's all. Rest the Springboot framework should take care. Let's build this and see if it is building successfully. Edit configuration, add Maven, clean, and package apply. Okay, let's see if the jar is built successfully. Yeah, build is successful, and if you go to the jar, yeah, we can see authorization application.jar. The jar has been created. Now let's run and see if this application is coming up. So for that, again, edit configuration, maven key, sorry, maven, and here Springboot run, apply. Okay, let's run and see if everything is working fine. Fine, the application has started successfully. So that means our authorization application is ready. Now we can test this application using this client ID and this client secret and see if it is creating a token and sending back. So for that we use Postman to call this API, and in the Postman we will specify this URL, this client ID, and call this system and see if you are getting the response. Let's start with testing our authorization applications which we just developed, and it's just running there in the IntelliJ. So we'll use this Postman tool. This is a Postman tool, and here we will create testing request to test that authorization application. So we'll come here, we'll add a request here, which it is a post method, so we'll change to post, and it is running in, yeah, this is the URL. It's running in the localhost 8080, and the path is OAuth2 token. And now coming to authorization, basic auth. As I told here, this is our client ID, API client ID. So I have given API client ID, and password is API123 that we have given here. And the type is set as basic auth. This is why, because here also we specified the authentication method as client secret basic. That's why we have selected basic auth. Now coming to the body here, so we'll use this form URL encoded. So the key is grant type, here grant type, and this one client credential. Grant type is client credential. So that's all, the body, the authorization, and the URL. We will save this here, and now we will try to send this and see if you are able to receive any response from the authorization application. Send here. Fine. So it's working. We got the token back from the authorization application. Now we'll just decode this token and see what all there inside that. And also you can see here it says per time is 36,000, which we already mentioned here, right? 36, that's what it has given here. So let's decode and see this token content. Okay, we will use this website to decode our token. So we'll paste a token here. So if you can see, the token contains three parts. One is a header, and there is a payload, and another is a signature. So header contains the algorithm used, and the payload contains the claim details, circle the claims, and then it contains the signature detail. So basically this token is signed one, that's only signature part is shown here. So this signature will be verified in the other microservices where we are sending this token. So there it will verify with the JWK, which I defined in the technical section. So that application where the token is verified will call the authorization application to get the JSON web key, and then verify this token and make sure it is signed by the authorization application only. Okay, so we will change this URL name to token. Now we'll also test the JWK URL from our authorization application. So we'll come here, and here we'll give name as JWK. Here also it's the URL. We copy here. The path is JWKS and it is just a get. No need of authorization, nothing. It's an open URL, so any system can call and get the web key. So we get here, yeah. So you can see the key sent back from our authorization application. So this key will be used in the microservice or anywhere where our token has to be validated. So this key URL will be called, they will receive, that application or system will receive this key, and based on this key it will verify the signature of that token. So anyone who send an invalid token or a tampered token, so there this signature verification will fail. Thereby we ensure that our tokens are secured. We'll save this as well. Now coming to the token payload, if you can see, this contains only the details like issuer, the client ID, and the expiration time. Now when I was explaining the technical design, we also need some user details. This is because the flow is like from the user authentication service. When a user is authenticated, the user authentication service will call this authorization application on behalf of the user to create a token on behalf of the user who was authenticated there. So that means the token should contain some user details so that this can be used in other service, because whenever a microservice, other service is calling there, if you want to check the role of the user, because only user with a particular role is allowed to access a particular API. So the role detail should be there, so that should be there in the token. Same way, username or an user ID to uniquely identify the user. So because once the token is generated, then we will not share the user credential to other microservices. We only share this token. So the token should contain the details specific to user, so that the microservice, wherever the token is received, can decide what all the access this can be given to this user. So this has to be added to the claim. So to add that, in our project we have to create a configuration class through which we can add that claims, which are called custom claims. So we'll create a new package here and name it as config. And now we'll create a class. We'll create as custom claims config and annotate with that configuration annotation. Here we will create a bean public OAuth2 token customizer. We'll give this JWT token customizer. What this class is. Return So we will check here the token type is access token only. Then we will add the custom claims. So from this context we will get the claims. Yeah. So here we need to add the custom claim. So what our custom claim we have to add is we need to add an username. So we need here username, and the value we'll decide later, and other claims are user ID, user provider. So user provider, why? Because we are using a third party OAuth provider also in our system, like Google. So to identify that user, whether this user was registered from the Google or from our local system only, we are having this claim, so that the other microservice can understand. And the authorities to define the role of the user. So this, but now from where we will get this value, because these user details are present only in the authentication service, but we are putting the claim in the authorization application. So we should get this data from the authentication service only. So that means when the authentication service call the OAuth token URL, at that time it has to pass this value along with that, so that we can set that value in this token as a claim and send it back. So the only way we can set is in the HTTP header. So we will auto-wire the servlet request to get the HTTP header and post that values present in the header in these claims. So auto-wire private HTTP servlet request. So give request.get header, the name of the header. So here it will be like user. This is what we will pass from the user authentication service when we call the OAuth token URL. So here the user role, and user can have multiple user role, so it will come as a comma separated roles. So comma separated string value, so that has to be converted to a list value. So that's only we are splitting that based upon the comma and then converting it to an list. There is no value present header, just to we are setting an empty list. So that's fine. So now let's restart this again. Okay, I have pressed start again. Let's go to the postman and see if we send this header details, will we get that in our claim, in the token claim. So coming to the postman here, so we will add the custom headers which we created there. So username, user ID, user provider, user role. So here username will be code with Manish. User ID, just give 1 2 3 4. User provider, we'll give local, and user role as for time being we'll pass only one role, role user. Right. Now let's save this and send this and see whether the token will have this. So we have got the token. Let's decode it and see if these custom claims are there in the token. Okay, so now you can see here username, user ID, user provider, and the authorities. This is what we set in the custom claim. Yeah, so now our token is capable of supplying user details also to any microservice where this token is being sent. So coming back to the design document, we have completed this part, the authorization application part, and we have tested also. We tested with sending a client ID and client secret and the user details in the header, and the application was successfully able to create a token and send back. So this part is over. So now we have to develop an user authentication service, front-end application, and a sample microservice to do the end-to-end test. So in the next video we will develop an user authentication service. That's all. Bye.